Well, thank you very much. My name's Kevin Shaw. I'm Chief Technology Officer at Sensor Platforms. And I want to spend the next half hour or so talking about visual systems and inertial systems and how the two of them can work together to solve a broad range of problems. First off, I'd like to motivate the conversation and take a look at the markets that are served by this. First off, we've seen the use of vision systems in games. Well, mobile platforms more than anything. It is a remarkable state of affairs that we have smartphones, small little phones, that basically have the computational power of what was a supercomputer a decade or two ago. They have the battery, CPU, graphic processing unit, and, a high-def camera that'll go in with it. This is what we're seeing in computer games now. They've done amazing things, but I think there's more that these can do from a gaming perspective. And then there's augmented reality that is being serviced by computer vision.
It is. Okay, great.
This has also been very hyped in the past several years, but it hasn't really taken off yet. I was looking at some of the examples at AWE earlier in the week, and I'm still seeing images that bounce around and that jump around. I still haven't seen the level of accuracy that I'd like to see. And then there's indoor navigation. There's a lot of companies and a lot of technology trying to service the indoor navigation market, and vision could be part of it. Why not? I'm standing here walking around here. I'm not bumping into things. I'm using a computer vision system. Human vision system. It works quite well. Why could that not be part of the indoor navigation solution? Well, it's tricky. And I will go into some of the reasons why it hasn't so far. Oh, and of course, power. Power is a major one of them. How do we solve an always-on computer vision problem? I'll hint a little bit at hyperphotography, which is the ability to get more information into a computer or into an image than is actually there. And robotics. It goes without saying that most of the terms we're going to hear in the computer vision world come from the robotics world. A lot of the development was done there for a very simple reason. If I wanted to have a mobile camera going through a field, I probably had to have a car battery sitting next to it, and a wheeled system, and a computer on it. Back when most of this stuff was done, they were quite heavy, and then you needed the large platform. And so we'll talk a little bit about visual odometry. All of these are drivers for the vision system market. Also, you can go into things like computer construction equipment, where you want to have perimeter safety, identify people around you. All of these are needs for a strong and stable vision system. I also want to touch on context awareness. We saw that in actually just the presentation a moment ago. Allowing a computer system, a handheld system, to understand not just the world around you, but what you are doing. What am I doing? In the Samsung Smart Stay, for example, identifies whether you're looking at it, and when you turn away, it stops your movie or dims the display. Vision systems can be used for a contextual understanding of the user themselves. And then there's the critical shift here. We hinted at the robotics and then the shift to the mobile here, but also the shift to the wearables. And I'll address this a little bit more in just a moment. But this is a very important one. And then natural interfaces. I interface with the world. Most of the information that I bring in, yes, I listen, but I also see. And this is such a natural way of viewing the world that I have to ask the question of why don't mobile devices see the world and feed me information in the same way? The example is given here of identifying a medicine bottle in front of me. This is sort of a natural state of where the information comes in, not just of understanding the walls around me, but understanding what I am interacting with and feeding me additional information.